Everyone's shipping agents, but most demos hide the architecture behind a single chat box. Today we dissect one realistic reference design, an agentic workflow built on Semantic Kernel orchestrating Azure OpenAI. We'll walk the actual flow of a request, from the user prompt to a tool call to a grounded answer. You'll see why each component exists, where the agent loop can go wrong, and the trade-offs an architect makes around tool calling, memory, and cost. By the end, you'll have a concrete mental model you can map onto your own build, plus one takeaway you can apply this week. Here's the architecture. The client hits Azure API management, which handles auth, rate limiting, and routing. Behind it, your agent host runs in container apps, embedding the Semantic Kernel runtime. The kernel calls Azure OpenAI for both chat completions and embeddings. When the model decides it needs information, the kernel invokes a plugin that queries Azure AI search for grounding documents. Secrets like the OpenAI key live in Key Vault, pulled at startup via managed identity. Notice the kernel is the hub. It owns the conversation, decides which tool runs, and assembles the final context window sent to the model. The heart of an agentic workflow is the loop, not a single call. The kernel sends the prompt plus a list of available functions to Azure OpenAI. The model responds either with a final answer or with a function call request. The kernel executes that function, appends the result to the conversation, and calls the model again. This repeats until the model produces a final answer or you hit a configured iteration cap. Semantic Kernel manages this loop for you through automatic function calling. The key insight: the model isn't running your code, it's requesting calls, and the kernel decides whether and how to honor them. Plugins are how you give the agent real capabilities. In Semantic Kernel, a plugin is just a class whose methods are decorated and described. The descriptions matter enormously, because the model reads them to decide which function to call. A vague description means wrong tool selection. You'll typically mix native plugins, plain code that calls a database or API, with semantic functions that are themselves prompts. A good rule of thumb: keep each function narrow and single purpose, and validate inputs yourself. The model will sometimes hallucinate arguments, so treat every tool call as untrusted input crossing a boundary. Here's the minimal wiring. You build a kernel, add the Azure OpenAI chat completion service with your deployment name and endpoint, register your plugin, then enable automatic function calling through the execution settings. That last line is what turns a plain chat call into an agent loop. Notice we pass a deployment name, not a model name, because Azure OpenAI routes through your own deployment. Check the current Azure docs, since the Semantic Kernel API surface and the function calling settings have changed across recent versions. Now the failure modes, because this is where real systems live. Runaway loops. The model keeps calling tools and never converges, so always cap iterations and set a token budget. Latency stacks up fast, because every loop iteration is a full round trip to Azure OpenAI, and 3 iterations can mean 6 seconds or more. You also hit token per minute quota limits on your deployment under load, which surface as 429 errors, so build in retry with backoff and consider provision throughput for steady traffic. And tool errors. If a plugin throws, decide whether to surface the failure to the model or fail the request outright. The core architectural decision is autonomy versus control. Full automatic function calling lets the model chain tools freely, which is flexible but unpredictable in cost and behavior. The alternative is a structured approach, where you constrain the model to choose from a required set, or you orchestrate steps explicitly in code and only use the model for the reasoning at each node. My opinion: start constrained. Give the model fewer tools and tighter prompts. Measure. Then loosen autonomy only where it earns its keep. Observability is non-negotiable here, so wire up application insights and log every tool call and token count. To recap, The kernel is the orchestration hub. Azure OpenAI is the reasoning engine. Plugins are your tools with descriptions that drive selection, and the agent loop runs until convergence or a cap. The failure modes that matter are runaway loops, compounding latency, and quota throttling. Your one concrete takeaway: before you enable full automatic function calling, set an explicit iteration limit and a token budget, and log every tool call to application insights from day one. That single discipline turns an unpredictable agent into something you can debug and cost control. Check the current Azure docs for the latest semantic kernel and Azure OpenAI features before you commit a design. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.